On July 22nd, Canada had 900 active wildfires burning at once, part of nearly 3,150 fires that have already scorched more than 3.3 million hectares this year. That number alone would be alarming on its own. What made meteorologists sit up wasn't the fire count. It was what the jet stream did right above it, bending into a shape that determined exactly where all that smoke was about to go. A wildfire season this size is not unprecedented on its own. Canada has had brutal fire years before, and firefighting crews across the country are, unfortunately, experienced at managing large, simultaneous blazes. Taken in isolation, 900 active fires is a serious but familiar story, the kind that gets a few days of coverage and then fades into the background of a long, hot summer. What makes this particular stretch worth a full breakdown isn't the fires themselves. It's the jet stream sitting above them, which buckled into a pattern strong enough to physically redirect smoke thousands of miles away from where it started, carrying it deep into the United States on a route that isn't the normal path this kind of smoke takes at all. To understand why that matters, you need to understand what the jet stream actually is and why it doesn't usually behave this way. Picture a fast-moving river of air, several miles up, that circles the globe roughly west to east. Under normal conditions, that river moves in a relatively smooth, gentle wave, steering weather systems along a predictable path. Under certain pressure conditions, although that river stops moving smoothly, it buckles into sharp dips and ridges, sometimes looping so dramatically that meteorologists describe the pattern as highly indexed meridional flow, a technical way of saying the jet stream has stopped flowing mostly west to east and started swinging in wide, looping detours instead. The strength of that river matters too, and it's driven by a specific temperature relationship most people never think about. The jet stream exists because of the sharp temperature contrast between cold Arctic air to the north and warmer air to the south. The bigger that temperature difference, the faster and straighter the jet stream tends to flow, the same way a steeper hill produces a faster, straighter stream of water than a gentle slope does. When that temperature contrast weakens, the jet stream loses some of its driving force, and it becomes more prone to buckling, slowing down, and getting stuck in exaggerated loops, rather than moving briskly along its usual path. That is exactly what happened over North America in mid-July. Instead of carrying smoke from Western Ontario's fires, generally eastward in a straight line, the buckled jet stream routed it on a circuitous path, first pulling it southward, then curling it back around, delivering it into the northeastern United States on a route far longer and stranger than smoke from that region would normally travel. NASA atmospheric scientists, tracking the plume using satellite modeling, confirmed the smoke's actual origin was thousands of miles from where it eventually caused the worst air quality. Proof that the jet stream's shape, not just the fires themselves, was doing the real work of deciding who got smoke and who didn't. Here's where the evidence starts stacking. Because this isn't the first time this exact pattern is played out, and the history matters. In September 2023, a nearly identical setup occurred. Smoke from Canadian wildfires got steered on an unusually far southward path specifically because it had to bend around a massive zone of high pressure parked over central North America, a configuration meteorologists call an omega block, named because the jet stream's shape on a weather map physically resembles the Greek letter omega. That block didn't just sit there passively, it acted like an obstacle in a river, forcing the smoke to route around it rather than through it, pushing the plume much farther south than its usual late summer path. An omega block and a simple jet stream buckle aren't identical phenomena, but they share the same underlying signature, a normally fast-flowing, relatively straight current of upper-level air getting stuck in an exaggerated, slow-moving shape that traps whatever weather, or in this case, smoke, happens to be sitting beneath it. Meteorologists who study these blocking patterns note that once one locks into place, it can persist for a week or more, which is part of why both the 2023 event and this July's pattern produced smoke transport that lasted so much longer than a typical few-day plume. The same pattern showed up again in the summers of 2024 and 2025, each time carrying Canadian wildfire smoke across the border and into the American Midwest and Northeast on jet stream-driven detours. In July 2024 alone, nearly 989 fires were burning across Canada by late month, more than half of them in British Columbia and Alberta, with extreme heat, wind, and thunderstorms all contributing to their spread and to how far the resulting smoke ultimately traveled. What's happening this July isn't a one-off anomaly. It's the fourth consecutive summer this specific mechanism, a buckled or blocked jet stream physically rerouting wildfire smoke across international borders, has shown up in the data. What's different this time is the persistence. Earlier events tended to resolve within a week or two, as the pattern shifted back toward a more typical west-to-east flow. This July's configuration has held long enough that forecasters are now projecting periodic smoke events continuing into August, not because the fires themselves are necessarily getting larger, but because the atmospheric traffic jam steering their smoke has proven unusually stubborn about breaking up. Like and subscribe if you want breakdowns like this one, the kind that connect a weather pattern most people scroll past to the actual air people are breathing hundreds of miles away because this pattern isn't done showing up yet. Now bring in the ground level consequences, because this is where the science stopped being abstract for millions of people. On July 17th, as a frontal system pushed the smoke plume downward toward the surface instead of letting it disperse aloft, daily average fine, particulate matter concentrations in the Baltimore-Washington, D.C. area approached 200 micrograms per cubic meter, triggering code purple air quality alerts, one of the most severe categories on the scale. That kind of concentration doesn't just mean hazy skies. It means air quality bad enough to pose measurable health risk to the general population, not just people with pre-existing respiratory conditions. The health data behind that alert level is worth sitting with. A 2026 study published in Science Advances estimated that exposure to wildfire smoke fine particulate matter contributes to roughly 25 to 100 deaths annually across the affected regions studied. That figure isn't tied to any single smoke event. It's a running toll, accumulating year after year, driven substantially by exactly the kind of long-range smoke transport this jet stream pattern keeps producing. Children, older adults, pregnant women, and anyone with asthma, heart disease, or other respiratory conditions are consistently identified as the highest risk groups when this kind of smoke settles over populated areas. Public health researchers point out that this risk extends well beyond people who already know they're vulnerable. According to recent national air quality assessments, nearly half of Americans already live in counties where fine particle pollution, ozone pollution, or both are severe enough to earn failing grades on standard air quality report cards, even before an event like this adds a long-range smoke plume on top of already elevated baseline pollution. That existing burden is part of why a single smoke transport event, riding in on a buckled jet stream from thousands of miles away, can push an already strained region's air quality into genuinely hazardous territory rather than just mildly worse than usual. Forecasters tracking the pattern say the smoke isn't finished traveling either, because the jet stream's current dip over the eastern half of North America is expected to persist. Prevailing northwest to southeast winds are likely to keep scooping up smoke from the Western Ontario fires and delivering periodic haze into the Midwest and Northeast well into August, or until enough rain finally falls on the fires themselves to put them out. Whether any given day brings clear skies or thick haze now depends heavily on whether cleaner air happens to mix in from the south or west, a level of day-to-day unpredictability that makes this kind of event genuinely difficult to plan around more than a few days in advance. Now here's where it's worth being honest about what's genuinely uncertain rather than settled. Some researchers, tracking the recurrence of this exact jet stream buckling pattern across 4 consecutive summers, have raised the question of whether a warming Arctic, which reduces the temperature difference driving the jet stream's normal west-to-east momentum, is making these looping, blocked configurations more frequent, rather than this being a coincidental run of similar summers. This remains a genuinely open question in the research community rather than a confirmed trend, and scientists studying it are careful to note that 4 data points, even 4 unusual ones in a row, isn't yet enough to separate a real shift in atmospheric behavior from ordinary year-to-year variability. It's included here because it's exactly the kind of long-range signal researchers are watching closely, not because it's been proven. It's worth being precise about what meteorologists actually can and cannot tell you about a pattern like this. They can forecast, with real confidence a few days out, whether the current jet stream configuration will keep steering smoke toward populated areas or allow it to disperse elsewhere. What they cannot do is predict weeks in advance exactly which specific day will bring hazardous air to any one city, since that depends on smaller scale shifts in wind and moisture that only become clear on a much shorter forecast horizon. That gap between confident short-range forecasting and genuine long-range uncertainty is one of the most persistent limits in this entire field, and it's a big part of why air quality alerts tend to arrive with only a few days of notice rather than weeks. So what does this actually mean if you live anywhere downwind of this pattern, which this July has proven can mean much farther away than most people would assume? Check your local air quality index directly rather than relying on how the sky looks outside, since fine particulate smoke can produce genuinely hazardous air even on a day that doesn't look especially hazy at ground level. If you or someone in your household has asthma, heart disease, or another respiratory condition, keep rescue medication accessible and consider limiting prolonged outdoor exertion on any day your local index crosses into the unhealthy range, regardless of how far away the actual fires are burning. If poor air quality alerts are common in your region, a properly rated air purifier for at least one main living space using a true HEPA filter meaningfully reduces indoor particulate exposure during exactly these kinds of extended smoke events. keeping windows closed and switching your home's air system to recirculate mode, if it has one, during a code purple or code red alert, also measurably cuts down on how much outdoor particulate matter makes it inside. And if you're planning outdoor activity days in advance, check the forecast, again closer to the date rather than relying on an early prediction, since this pattern has shown it can shift which cities get hit within just a few days. The wildfires themselves aren't really the anomaly here. Canada has fought large fire seasons before and will again. What's different this July, and what's shown up in some form for 4 summers running now, is the jet stream's willingness to bend into exactly the shape needed to carry that smoke somewhere it wouldn't normally reach. I'll keep tracking where this pattern moves next, and the moment the jet stream's shape changes enough to shift who's breathing that smoke, you'll see it here. 900 fires, one buckled river of air several miles overhead, and a health warning that reached a city thousands of miles from the nearest flame. That's the chain this July actually traced, one link at a time, and it's the reason meteorologists keep watching the shape of that river as closely as they watch the fires burning underneath it.